regression with Desmos to create the function that represents this table of data. This particular table of data has answer choices that are in a form of a quadratic equation. You'll know that because you can see the answer choices all here have your variable squared. So it is a quadratic. So we are going to start by entering this data into Desmos. The first step is to push the plus sign. You'll push the plus sign and you'll pick table. Next, and one thing before I keep going is you want to notice the number that is next to these variables. It's a number 1 if it's the first table you are using. We will be using that 1 in the regression formula. I'm going to type in here, I'm going to act like this, which they're calling t. I'm going to think that's my x, and this is my y. So don't let these variables being t and function notation over here, don't let that mess you up. Just like pretend it's x and y like normal. And I'm going to type in the data. So I have 5 and 3, and 10 and 10, and 15 and 17, and 20 and 27. Make sure you do this part right because your whole answer relies on typing this in accurately. I always have to be very careful about this part because I get distracted sometimes and will type this in wrong. 30 and 64, 35 and 86, and 40 and 112. Okay, so I've typed in all the data from the table. Next, you go to line 2, and we are going to write in a generic quadratic in standard form. This would be y equals ax squared plus bx plus c. But to do regression, we're going to use the squiggle instead of the equal sign. And next to the y, we're going to put a 1 because the y in the table has a little 1 next to it. And next to all the x's in the formula, we're going to put a little 1 as well. Same reason, we want to tell Desmos that we are using the table that has x sub 1, y sub 1. So we're going to start with y and then push 1. You don't have to do anything special. It will make it a subtext all by itself. Then we need the tilde. This is the piece that is often forgotten. You'll push the ABC, you'll get the squiggle, the tilde. And then we want to do a, and then x sub 1. So x and then 1 again. And then that needs to be squared. Plus, then we need b, and then we need x sub 1 again, because all your x's and y's need that sub 1, and then plus c, because this is the typical format of a quadratic. And whenever you're doing regression, the only difference between the typical format and what you're typing in is to have the 1 next to your x's and y's and the squiggle instead of the equal sign. So this is going to give you the correlation coefficient, which is how strong the relationship is. This relationship here, 0.9994, know that 1 is the highest this would go. So this is almost 1. This is a very strong relationship. Then they give you the A, the B, and the C. And these are the numbers that would go in the place of A, B, and C in the formula. So as we look at our answer choices, we want an A value of 0.07. And they even went one more. So 0.072. So as we're looking at our answer choices, we can narrow this down. It's not going to be this one because that's not the right number. 0.072 is in B and D. So we can narrow down our options to B and D. The next thing, looking at B, negative 0.1488. So our B value around negative 0.15. That is on answer choice B. And then you can check the C part, 2.73, 2.73. So the answer choice to this would be B, and we would have done everything within Desmos, just doing that regression equation. Now we're going to look at one more, which is exponential. So I pulled this one. This is actually coming from our Edgenuity lesson tomorrow over exponential functions. So I was thinking I could use this data. So what I'm going to do is I'm going to take this table and I'm going to put it into Desmos and I'm going to do the exponential regression for it. So to do this, we're going to push the plus sign. We're going to push table. And if this was a star question, they would have answer choices, of course, in exponential format. So we're going to type in the data 0, 1, 1, 2, 2, 4, 3.38. So we typed in the data. You can see the exponential kind of looks like a upward curve, and then one side will always look like a flat line, and it's doing that. And so we're going to do this regression formula for it, and the format is y equals ab to the x. Since my table again has x1 and y1, we're going to be putting those sub 1s, and we're going to use a squiggle again instead of an equal sign. So we're going to start with y1, squiggle, tilde, and then a, the formula for exponential is ab to the x, so we're going to put a, and then we're going to put parenthesis, and then b, and then parenthesis, and then in the power is the x. So you'll push this a to the b to get into the exponent, and we're going to put the x there, and we're going to put a little sub 1. That's the generic format of the exponential functions. They always have your x variable in your exponent. And you're going to learn more about the general formula as you go this week. We can see that our r value is 1 because this is actually a perfect set of data. And we can see that our a value is 1 and that our b value is 2. So for this equation, I would write it as y equals my a is 1, my b is 2, and then my exponent is x. And you could simplify this and say this is y equals 2 to the x. Because with an a value of 1, you don't really have to write that part. So that is how you use regression in Desmos to do quadratic and exponential. Let me see real quick if I have a linear. Because that way we would have had all three. Okay, here is a linear function, and it is a star release question. I know that it's linear because it has options that are all linear equations. So if I want to do a linear one, just that way we have all three, we're going to again start with the plus sign, add a table. It's x1, y1 again because I keep starting over. So we're going to have 1, 21, 3, 15, 6, 6, and 7, 3. And this will work anytime you want an equation from a table, you could do this. So it's super, super helpful. And if your table doesn't have the sub 1, if it's like a sub 2 or sub 3, all you have to do is use your formula and use that number instead of the 1. Now, since I'm used to x and y, I'm going to use x and y. I'm not going to use n as my variable here, so just kind of know that I'm using x and y instead. And we're going to do regression here. So we're going to put y sub 1, just hitting 1 gives you that sub 1. You're going to do the squiggle again. And the linear format is mx plus b. So we're going to have m, and then we're going to have x sub 1, and then plus, and then b. And this is going to give us our correlation coefficient, and it's going to give us m and b. Keep in mind that with linear, it's giving you a r squared and an r. The r value that doesn't have a squared there is going to tell you not only how strong it is, but if it's positive or negative correlation. This has a negative correlation because this data, as you go to the right, it goes down. So it also is an extremely strong correlation because 1 is the highest you can get. So this has a strong negative correlation. The slope is -3, and the y-intercept is 24. So we can look at our equations, look for a slope of -3 and a y-intercept of 24, which would give us answer choice F. And we'd have the answer to the table. So that's how you do regression with a linear function.
45 times 8.